Hello, I wanted to go over some of the basics of dimensional analysis and then do a couple of calculations dealing with moles. First of all, the process behind dimensional analysis is a mathematical way of converting one unit to another unit. For example, a football field is 120 yards if you count the end zone. And so if I were to ask how many inches or how many feet, we need to convert from yards to feet or yards to inches. And the matter is, well, do I multiply or divide by these conversion factors? So dimensional analysis takes the guesswork out of it. So after writing down the number, you write 120 yards, x for multiplication, x line, drag down the unit. And that's going to be the setup for most of our problems throughout the year. X line, drag down the unit. Now for this one, let's just convert to feet. And now you just need a statement, a mathematically true statement to convert feet to yards. And many of us know that 1 yard is equal to 3 feet. And so this is actually the entire problem of how to convert yards to feet. This way of dimensional analysis is useful when you can do something called drawing your diagonals. You have the unit yards in the numerator and the unit yards in the denominator. They would cancel out. Mathematically, 2 divided by 2 equals 1. 5 divided by 5 equals 1. 2 million divided by 2 million equals 1. Anything divided by itself is 1. And so that doesn't work with words, but the symbolic nature of it does work. And so we're left over with feet, which is the question I asked. And so you multiply the numerators, 120 times 3, divided by the denominators, 1, and you get 360 feet in a football field. And this you can do again and again and again, and you can do it for moles. You can do it for molecules. And so what we can do here is 25.0 grams of H2O, and how many moles are in that. Well, this is the new content, but it's X line, drag down the unit. We're not dealing with yards and feet anymore. We're dealing with some chemistry things, but it's still X line, drag down the unit, convert to moles. And then it's a matter of, well, how do you convert moles to grams? And again and again and again, we'll kind of refer to the same things, that this is something that you can do with the molar mass. And you can get the molar mass from the periodic table. The molar mass of H2O would be 2 hydrogens, which is 1.0079 plus 1 oxygen. Again, this is the molar mass is obtained from the periodic table. It's the decimal number as opposed to the atomic number. Add these up and you get 18.0148, 1 mole. And so if I were to have 1 mole of water molecules, it would weigh 18.0148 grams. So that's that true mathematical statement, just like saying 1 foot is 12 inches or 1 yard is 3 feet. This is the mathematically true statement. 1 mole is equal to 18.0148 grams of water. Again, your diagonals work out, grams of water on the top and the bottom, and you're left with moles. You can multiply this, round to proper sig figs, and you'll see that it matches our answers of 1.39 moles of H2O. Another type of problem that you can do here, skip down to number 3, how many molecules are in 23 moles. So as opposed to how many grams, now we're talking about moles. So same thing, 23.0 moles of oxygen, diatomic. X line, drag down the unit. That does not change. We're trying to get to molecules. So now we need to know a way to convert moles to molecules. That is not molar mass. Molar mass is specific for grams to moles. This is moles to molecules, or any particle in general, is defined by Avogadro's number. 1 mole is equal to 6.02 times 10 to the 23rd. Just like 1 million would be 1 times 10 to the 6th, 1 billion would be 1 billion equals 1 times 10 to the 9th, 1 trillion would be 1 trillion is equal to 1 times 10 to the 12th, 1 mole is equal to 6.02 times 10 to the 23rd. Drawing your diagonals still work. You're left with the molecules. I've lost my ink for a moment. I'll get it back. I'm left with molecules, and now all I need to do is, again, multiply the top numbers, divide by the bottom numbers, 1.38 times 10 to the 25th molecules. So these are the two types of conversions that we can do at this point. So now we go to number 2, which is like number 1 or it's like number 2. And so many of the steps repeat, but you're using different numbers. You're using a different order of operations in terms of not just multiplying and dividing, but what is the question asking for? So number 2, it's saying how many grams. So do you use the molar mass like we did in number 1, or do we do Avogadro's number like we did in 3? Well, you have to make note of all the key words in the question. Mass or grams. Whenever that's mentioned, you're going to need the molar mass. So it's going to look like number 1. We're going to do a similar conversion to this. But again, number 1 is asking for how many moles. This one is a bit different. This one is saying how many grams. So can't just copy and paste numbers, can't copy and paste steps, but I can copy and paste the logic behind it. We will write down the first number, 4.50 moles of lithium oxide. X line, drag down the unit. MOL is just shorthand for moles. Li2O. Question is asking for grams, so I'll put grams on top. Now, what number goes here? 1 foot equals 12 inches. 1 mole is equal to how many grams? Will that be the molar mass? 2 lithiums, which is 6.941, plus 1 oxygen, 15.999. Add those up and you get 29.881 equals. Again, you can draw your diagonals. Moles lithium oxide, moles lithium oxide. I'm left with grams lithium oxide. So I know I've crossed out the units I need to cross out. I'm left with the unit that I was looking for. Multiply the top numbers, divide by the number in the bottom, which in this case is number 1, but that's not always number 1. The issue that's always is that it's 1 mole is equal to X grams, X being the molar mass that you derive from the periodic table. Put that into your calculator and it matches with the given answer, 134 grams of lithium oxide. So you can practice this. Some of the steps seem like it's the same thought process every time, but you're doing them in a different order. You're pulling different numbers from different places in terms of, is it the molar mass or is it the Avogadro's number 602 times 10 to the 23rd? It takes practice, but I'm confident that you will do well.